I genuinely hope you are getting a little bit bored with these equilibrium problems, because bored, not that they're uninteresting, but bored that you just keep seeing the same thing over and over again. Because hopefully that means it makes sense. Because what we're doing in sample problem 18.11 is we're looking at determining the pH of a weak base solution. And so again, I'm going to just run through this problem fairly quickly, and we're just going to treat this the exact same way as we've treated all other equilibria, the same steps. And the first step is to write our equation. So we've got CH3,2NH with water is going to generate CH3,2NH2+, generating the conjugate acid. And because we took that proton from water, we leave behind hydroxide. Because I wrote a problem showing my species behaving as a base, I write Kb. Kb is going to be equal to the concentration of hydroxide times the concentration of CH3,2NH2+ over the concentration of CH3,2NH. Okay, for this problem, they give us that value. They give us that value as 5.9 times 10 to the minus fourth. So I wrote my relevant equation. I wrote the associated equilibrium constant for that. Again, they give us that. And we just need to make sure that everything is in the right, correct starting units. So we've got CH3, 2NH initial, and they give it to us directly as 1.5 molar. So our preliminary steps: equation, equilibrium constant, initial concentrations. We're going to make our ice table here. We've got 1.5 molar to start. Water's not part of our equilibrium expression, and we're assuming that we have no contributions from other species to either hydroxide or our conjugate acid. We lose a little bit here, gain there, 1.5 minus x, x and x. Our Kb is then going to be equal to x times x over 1.5 minus x. We're going to make an assumption that x is small. We'll have to check our assumption afterwards. So x squared over 1.5 is going to be equal to 5.9 times 10 to the minus fourth. Again, that's our Kb value. Solving for x, x is equal to 3.0 times 10 to the minus second. And that's equal to hydroxide concentration. So be very, very careful. If you just take the negative log of 3.0 times 10 to the minus second, you are going to get 1.53. This is POH because this concentration was hydroxide concentration, not H+. So we need to take 14 minus POH to give us pH. And so pH will be equal to 12.48. Now keep in mind here, one of the things that you want to make sure, I should say this is 5.2 here. One of the things that you want to make sure that you know ahead of time is predict acidic, basic, neutral. Predict what you think the pH or the acidity of that solution is going to be. If we had looked at this and saw, hey, dimethylamine, that's an amine. I know those are weak bases. That should have a pH greater than 7. I would predict that solution to be basic. If you just took negative log of this because you'd been doing a whole bunch of weak acid problems and got 1.52, that should send alarm bells off in your head that that's not a pH, that's a POH. And you need to convert that into a pH, again, being greater than 7, that reflects the solution being basic because we have an amine compound. So have that logic hat on so that you're better able to think about and predict what the relative acidity or basicity of the solution is. Last thing, we didn't do our check. So our check here is going to take what our x value was, 3 times 10 to the minus 2. And we're going to divide by 1.5. And I didn't do this, so let me just do this real quick. 3 times 10 to the minus 2 divided by 1.5. That ends up being 2%. So I kind of call this a post check. If you want to get in the habit of doing what I refer to as a pre-check, that's going to require you to take the amount that you have. So it's going to be our our base concentration initially, put it over the Kb value, and again we want something that's greater than 400 for this. So we had 1.5 divided by our Kb, which is 5.9 times 10 to the minus 4th, and this equals 2,542. Definitely greater than 400. So again, if you want to do a pre-check before you start that, that's valid for your assumption. Or if you make the assumption without the pre-check, you need to do your post-check to figure out that it's less than 5%.